Okay, so let's move on to this market stuff. Now, what I've given here is an example. We've done in class already. Something similar to this. Two people, one with one demand curve, the other with another. The demand curves are both linear, but they have different choke points, different slopes, so different points where the marginal reward of the next unit goes to zero. So they're different demand curves, they just both happen to be linear. I've given you both the demand as well as the inverse demand. And so if you want to verify that you really are doing understand this stuff, it might be interesting to sort of verify that if you took one of these demand and inverse demand things, because they're inverse functions, you should be able to verify that if you plug in a price, you'll get a particular quantity demanded out. And then if you plug that quantity demanded in to the inverse demand function, you'll actually get that price out. So that's all I'm saying here. You could verify that these two are inverses of each other. And if you get comfortable with that exercise, that gives you a great way to check your work whenever you manually have to derive a demand function from an inverse demand or an inverse demand from a demand. Right after you get it, if you've done it correctly, you should be able to do this little calculation where you plug in a p into the demand function and then the quantity demanded into the inverse demand, and you should get the p out. Or vice versa, you could plug a quantity demanded into an inverse demand function, and then I'll give you price out, then plug that price into the demand function and see if you get the quantity demanded that you started with back out. You always should if you did the inverses right. All right, but that's just sort of on the side. What I really want to know is if these two are joining a market to each other, they're the only two consumers in the market, what does the market's demand function look like? Okay, so they have different choke prices. So that means that there are going to be some prices in which case the person on top, she will still be willing to participate in the market while he will not. So if the price is $80 per unit, then that is too much. He doesn't value any of the units, first, second, third, whatever. He just does not value them enough to pay $80 for it, but she still does. So she'll be the only one in the market. Now, once the price drops to below 75, then suddenly he will join in and the quantity demanded will jump up at that point. So we have to be able to properly model that. So what we're expecting is some function that looks kind of like this. So the down here I have when the price is low, the market quantity demand is the sum of both of theirs. And when the price is high, it's just equal to hers. So that's what I want to do. Now, I've given you two people, but you could also imagine that I gave you like a whole market demand and then one single person being added to the market. And then you have to decide, well, when does that person actually get added? So you have to figure out what their choke price is, and then make sure you only add them in for prices less than their choke price. Okay, so let's see how to do that. So I just took the exact same expressions that I had on the previous page, and I said, well, if the price is less than 75, that's what this little thing here, this is combining those in a piecewise way. If it's less than 75, I copy her demand function down, and then I add in his demand function. And so that's all that we see there. And so, and then down here, when the price is too high, it's just hers. So the next step I need to do is just to simplify this line. And so I'm going to combine the constant terms. 50 plus 150 will give me 200. And then I'll combine these the linear terms. And so minus 0.5 minus 2 should give me minus 2.5. And if I've done the math right, there we go. So that's just what I was saying. So this down here is just a copy of hers. And this up here is the combination of the two. And this is only for low prices, and this is only for high prices. So what does that look like? Well, again, when we plot these things, we actually plot the inverse demand. So it's useful to invert these. Well, now I have to invert something that's piecewise. So that's a little complicated. So how how do we do it? Well, the inversion will probably be piecewise as well. So we have to think about, well, okay, so what are these two pieces going to look like? So the inverse demand function should have a region that corresponds to this low-priced region. So if I look at the low-priced region, it goes from 0 to 75. If I plug 0 into the quantity demanded, that gives me 200 out. So that's the 200 here. If I then raise the price to 75 and plug 75 into this, well, 200 minus 2.5 times 75 is 12.5. So this tells me that at 75, I'm going to have a quantity demanded of 12.5, and that is going to end up being one of these critical corner points in this graph here. So that's the range for this bottom one. And then, so the range for the top one, well, I kind of know because there's only two ranges, it's going to go from 0 to 12.5, but just to verify that, if I go here and I plug in a 75, so this is this bottom range, I plug in a 75 into this expression, 50 minus half of 75 versus 50 minus half of 100. Well, you know, 50 minus half of 100 is going to give you 0, and so 50 minus half of 75 is going to give you 12.5. So this range corresponds to this range. So now that I have this, like, I know that this bottom piece corresponds to this top piece, and this top piece corresponds to this bottom piece, then I can invert the pieces just like I would as if it was just one without the pieces. So that's what I'm going to do. I then focus on that, that bottom function, 50 minus 0.5p, and if I just for this little section, set q equal to 50 minus 0.5p. So if I set q equal to 50 minus 0.5p and then solve for p, then I will end up getting an expression 100 minus 2q, and that's what I put here. So then I have to flip to the other one, and so I would set q equal to this. Well, I want to solve for p. So then I solve for p, and then I would end up getting p is equal to 80 minus 0.4q, and that's what goes in this bottom expression. So now I have a demand function that's in pieces, a piecewise demand function, and I also have a piecewise inverse demand function. And this is actually what I will end up plotting. So this looks like a line, and this looks like a line, so it might be useful to plot those two lines and then cut off the regions we don't use. So maybe we'll try that. So I'm going to look at this, this top portion here, and sorry, top in the demand and bottom in the inverse demand. So these are the same lines. It's just two different descriptions of the same lines. And because I've got both of these functions, I actually know both intercepts. I know from the inverse demand function, this is the y-intercept, that's the 80. And I know from the demand function, this is the x-intercept, that's 200. And I know because there are lines, I can just connect them with a straight line. Or, I mean, alternatively, what I could have done is I know this is the y-intercept, and then I could have then plotted a line with this slope, negative 0.4, and that would have given me the same line. So that's that line. So then let's shift and say, all right, well, for this other line, I know this is the x-intercept and that's the y-intercept, so that's the other line. So basically what we're going to do is we're going to say, I see. Well, so I'm going to follow this line for high prices, and once I hit this point, that's when the second consumer is going to kick in, and then I'll follow this line for low prices. So let's do that. This is our market demand curve, where this is just that the one with the high choke price. So that's this one. We're just following down, and then at this point right here, when the price is 75, well, yeah, that's exactly what we want. Look at that, 75. So at exactly 75, we've hit the choke point of the new person, and their demand starts adding to the first person's demand. And that additive effect creates this kink in this curve. And there we go. All right, so so that is how we formulate the market demand. And I hope you can start seeing that even if we start out with boring individual demand curves, when you start adding them up this way, you start getting funky shapes out. So a true market demand curve, even if we're thinking of the individuals as little lines, the market demand curves might be very different looking. So, uh, so that's why the kind of calculus behind the PED is important, because you might end up having to take derivatives of interesting functions and things like that. So we'll get into the PED calculations in a second. So, but for now, jump back to Canvas and answer a couple of questions about how you combine these market demands together. So get a little practice in doing that, and we'll come right back.